And they're all implicated in lipid metabolism. They also have signaling and immune regulation, which is interesting because maybe they're functioning to help protect against that chronic intestinal inflammation, which we think could be at the heart of malnutrition. This is a team. Joe Mishkaleski is the biostatistician that analyzed the data. Pat Kincannon actually did the genome-wide scan. Steve Rich coordinates the center. Eric Haupt and Mami Tanayushi did the microbiology. Christine Peterson, biomarkers. Data analysis, a team, really crucial people, and then of course the leaders at the ICDDRB. Well, where do we go from Bangladesh? Is what's true for malnutrition in Bangladesh going to be true in sub-Saharan Africa? And Bangladesh is, if you're a gardener, is like a dream because it's all the floodplains of the major rivers in the Indian subcontinent. So the land is incredibly rich. There's actually like 3 growing seasons a year in Bangladesh with high-yielding varieties of rice. One of the reasons that, that country that is as small as the size of Massachusetts can support 130 million people. Well, you remember, though, the problem with malnutrition is not just in the Indian subcontinent, for example, in Bangladesh, but also in sub-Saharan Africa. And so if we go to the Gambia, we see the same thing. And here's, the Gambia is this really unusual, long, narrow country surrounding one river. And we're working there with Andrew Prentice, who in the Medical Research Council has had a long presence studying childhood malnutrition in the Gambia. And so one of the questions is, are the genetics of what we're seeing in Bangladesh going to hold true in sub-Saharan Africa? Very different situation in Africa. For example, in the Gambia, there's only one growing season. There's about 3 months where it rains. So a lot of the time, this is what the village that Andrew Prentice works in looks like. And here it is almost at the harvest season. This is actually the starving time, because sort of paradoxically, because all the food that was stored from the last harvest has been expended by this time, and yet they're not quite ready to harvest what has been grown in this annual season. And so, different situation where you have like a starving time and then the time where you're replete with food. And will we see anything that's similar? We don't know yet, and so we're just starting the work there. But if we look at the growth curves for children in the Gambia, it's remarkably reminiscent of what I showed you in Bangladesh. Again, like with this sort of like inexorable decline in weight, length, head circumference over the first 2, maybe even to 3 years of life. And so this suggests to me that it's this common biologic process that is in effect both in the Gambia and in Bangladesh. Next month, actually, we'll be receiving DNA samples from this child cohort in the Gambia to test those same polymorphisms in this remarkably different population. So just to close, there's just a few more photographs from the study. This is actually some of our team of investigators. This is Mark Davis at Stanford, who's doing work on T-cell responses in these children. Jeffrey Gordon from Washington University St. Louis, who is looking at the microbiome, work that I haven't told you about. Andrew Prentice from the Gambia. Mark Maneri from Malawi. The only person that didn't need an ID badge on was Bill, so. Because the assumption was everybody knew who he was. And then just a couple photographs to close. So I think, a lot with science, with public health, is choose an important problem, but it's not enough to choose an important problem. You've got to have a problem that you can actually come up with like some reasonable approaches to study. And I think thanks to the advances in human genetics today, that we really do have an opportunity to make an impact on a really important problem in public health. And again, thank you very much for having me here today. Thank you. So the question was about epigenetic modifications having a role in malnutrition. And I think that that's a very important point. If you notice, like, that the children in Bangladesh are really being born already malnourished, and so they're at -1. And so it really suggests that to fully understand this problem, we've got to do more than what we've been doing so far, which is just studying from 0 to 24 months and actually go back to -9, collect DNA on the mother, and I think begin to look at epigenetic changes, which are changes, for example, in DNA methylation that can be carried over from mother to infant and affect gene expression. So no, I think you put your finger on a very important part of the puzzle. Yes?
I was wondering about the thing about the chronic inflammation children. Were you saying it's naturally happening, like that's the way you're seeing that's being presented, or were they actually like being infected by some kind of disease and then having that chronic inflammation spring up?
Okay, so I think let me restate the question to be sure, but I think the question is what is the cause and prevalence of the chronic intestinal inflammation that I showed you, like the small bowel biopsy? What extent is that of a no known reason versus due to a known infection? And actually, this is when we met with Bill Gates, when I showed you that photo, the thing that he describes himself as an impatient optimist. And so he's optimistic that we should be able to make inroads on this, but he's impatient for us to do it. And he's very, I think, upset in a good sort of way that we can't measure that tropical enteropathy, because that's with a small bowel biopsy, and it's really not ethical to do that in a child unless you're going to have like you're going to be able to change like the health care of that child. And so we don't know how common tropical enteropathy is, and we're trying to measure it indirectly by looking at absorptive capacity of the gut, looking at endotoxin antibodies as a measure of a leaky gut. There's some other biomarkers that we're looking at, but it's a big problem with this study that I think that you've touched on, is that the thing that we think is most important, we can't adequately measure short of doing like an endoscopy and biopsy. And so we can't answer your question, like, is there specific pathogens that are causing that or more likely to cause that? What is the underlying pathogenesis of that inflammation? And so all I can say is, again, this is like a work in progress, but this is like when I go to Bangladesh this week, that's going to be a major topic of discussion, is how do we get our arms around what we think is like the main factor involved in malnutrition. Yes, Pat. Yeah.
I'm also interested in that absorptive capacity of the gut. So what are the implications of that? I mean, if you're right that it's quite widespread, whatever the cause, what are the implications of that for interventions in terms of supplemental feeding or expanded vaccination against diarrheal disease?
Yeah, so so if we discover that it is tropical enteropathy that's the cause, then maybe, not to be pejorative, but it's really kind of like, so what? And so what can you do about that? And I think if we find, for example, that there's certain enteric infections that are more likely to cause this chronic inflammation than a vaccine, against rotavirus, perhaps, that's being released now, maybe a lot of this problem will be solved by vaccines against the most common enteric pathogens. Maybe some of this inflammation is reflective of a nutritional imbalance. But no, I think that's an unknown open question with us, is if we do fully understand the pathogenesis, how is it going to lead to changes in treatment? And I think that's one of the wonderful things, the difference about the Gates Foundation and the NIH. The NIH is very supportive of blue sky science, so let's ask an important question and answer it. We don't care if it's going to make a difference in 5 years. The Gates Foundation is very much not only ask important questions, but how are you going to apply this? Bill Gates, like in November, another thing that he said is that he's measuring the success of his investments just as like a banker, and the way that he measures success is that 9.5 million children that are dying by their 5th birthday, and if he invests in this work, how is it going to make a difference in that number? And I think, frankly, we don't know right now. Rick.
You had a graph trying to make the point that food insecurity wasn't totally responsible for malnutrition, right? But it also implies that
Yeah, so I think, again, I think Rick's question, if you couldn't hear, is why would a food-secure household produce a child who's malnourished? And I would think that, I mean, the easiest answer, which may not be correct, is that, again, this tropical enteropathy. And so even the food-secure households have an open sewer, right out the front door sort of thing, and are dealing with fecally contaminated food and water and perhaps chronic intestinal inflammation. Yes?
Wouldn't that have something to do with the fact that just because you're getting enough calories, you're not necessarily, like, are these food secure houses, are they getting the right type of nutrients, or are they just getting a bunch of empty calories? I know that, like, some soldiers, like, the Civil War had problems, even though they were getting enough calories, they weren't getting enough nutrients.
Great. It's a really important question. So is it a lack of calories, or is it the quality of the food that's being ingested? And I think it's likely to be proven to be a combination of both. And I think that's part of this idea of the lipid nutritional supplementation, the realization of the complementary foods that are given. It's rice-based in Asia, and it's corn-based in Africa, and it's deficient in micronutrients, deficient in lipids, and so that's part of what's contributing. And obviously, if the children all ate as much as we do in the United States, presumably even with the enteric infections they're exposed to, that this malnutrition problem would mostly disappear. So it's a phenotype that's only being expressed because of a relative lack of calories and probably lack of quality of the food that's ingested. Just like the obesity epidemic in the United States, there's a genetic predisposition to obesity, but we never saw that phenotype until there was McDonald's, right, and supersize and stuff. So, yes.
That might have been already implied in the identity of the genes you found, but I'm not sure of that. You speak about the involvement of lipids probably as a fuel, but could it also be that the lack of lipids results in higher susceptibility to disease? It's not really the fuel and calorie issue, but rather the composition of tissues that we suffer?
Yes, I think, again, that's a really important point. The question was, is the lipid nutritional supplementation, is that working because it's added calories as fat, or is there actually immune or anti-inflammatory properties? And of course, one of the things that's put in the lipid supplementation is linoleic acid, which is really important in eicosanoids and prostaglandins. And so the lipids have very profound immunologic inflammatory effects, and presumably that's part of how they're acting to be beneficial. Yes?
We wouldn't expect that pregnant, like women who are malnourished would give birth to a child who is malnourished. But this is not the case. What might be physiologically explained?
I couldn't hear. Could you? Sorry.
Like a malnourished woman would give birth to a malnourished baby. So this is not the case according to what you have explained. So what might be the reason why those women give normal baby?
Okay, so and I partly kind of overstated. I think our own data, the malnourished mothers in Bangladesh are giving birth to well-nourished mothers, but they're at the lower end of normal for being well-nourished. They're one standard deviation below the WHO norm. And the question is, why would a malnourished mother give birth to a well-nourished child? And well, there's a lot of us in this room study parasites. Don't take this the wrong way, but there's no parasite that is better than the placenta. The placenta is going to take everything from the mother that the fetus needs for normal development. I think that's like why my friend's mother's teeth fell out when she gave birth to him, is that so much is resorbed from the mother so that the baby has like a fighting chance when it's born. But again, like this is only part of the story, and I think like the earlier question, I think that there clearly are maternal impact of maternal malnutrition on the health of the child.